The H-sync and V-sync signal were responsible for creating the tracing pattern for the electron beam. And while the electron beam is moving, we have to provide the different intensity values for the different colors as well. Basically, the pixel data at a very specific rate. And that rate is what we call the pixel clock rate. And that pixel clock rate has to conform with whatever the H-sync is doing, whatever the V-sync is doing, and also with the refresh rate that we want, which is 60 Hertz. So how do we compute that pixel clock rate? Well, it's pretty straightforward. The pixel clock rate can be computed using this particular equation, and this particular equation actually tells me, okay, so you're going to take the P, which is the number of pixels in the horizontal scan, which is here, and L, which is the number of lines in the horizontal scan, which is all the one numbers in here, and S, which is basically the number of screen per second. And that's basically incorporate the three things that I talked about, which is actually the scan, the horizontal scan, the vertical scan, and also the refresh rate that you call. So let's, for the sake of argument, just basically, or for an example, let's figure out what is the clock rate or the pixel clock rate for the VGA resolution, which is 640 by 480. So if you take a look at it, it's usually, we're going to have to say that the P is usually, which is the number of pixels in a horizontal scan line. You might be thinking like, hey, I have to use 640, and the answer is no. You need to actually use that 800 in here, because we also need to account for the borders and the retracing. So that actually tells me that you have 800 pixels per line, okay? And that basically is the P. So how about the L, which is basically the number of lines on screen? Again, it's not the 480 in here. It's actually the other number, which from a different when we talked about the vertical scans, we figured out that actually it's a 525, and that's basically lines per screen. Okay. And then what do we have? Well, what's left is actually S, and S, we know that it has to be 60 Hertz, or actually it's 60 screens or frames per second. We're going to call it screens, and this is what I called it for the L, per second. So if you multiply all of these together, for example, you multiply this number by this number by this number, you'll get the pixel clock rate, which is 800 times 525 times 60, and that gives me about, let's say, approximately about 25 mega clocks per second, or megahertz. Basically, that's basically clocks per second. Okay, so we need 25 megahertz in order for us, and that's basically the pixel clock rate. So whenever you're actually generating these, the H-sync and the V-sync have counters. They're basically based on counters. These counters have to be operational or enabled at that particular clock rate, which is 25 megahertz per second. And also the pixel data has to be provided at 25 megahertz per second. And this guarantees that you're going to have the exact pixels at the exact correct location. So that's what we call the pixel clock rate. However, this is not the pixel data rate, it's the pixel clock rate. This is actually the clock that you're doing. The pixel data rate is a little bit lower because the actual pixels were within the visual here, it's actually a little bit less. And that actually you obtain by multiplying the 640, instead of 800, you're going to multiply 640 times 480, which is actually the VGA resolution times 60, and you're going to get approximately, I believe it's 18.4 megahertz. It's a little bit less because that basically tells me that the number of pixels that are visible is less than the total number of pixels within the frames and whatnot. The reason why I'm talking about this, because if you're designing some sort of a system, this is what you need to use in order to do the scanning, but this is what you need if you're actually generating these pixels on the fly. This is actually the rate you need to operate at. So, well, at least this is the one. You can operate at a faster rate, but this is what you need.